Hi, a very good morning to all of you. I'm Gary, I do the video, but I was given the honor to introduce this fine gentleman who happens to be my very good friend, Richard. He's gonna introduce you some things about monitoring and observability. So Richard, please come up. He's the Director of Community at Grafana Labs, so give him a warm welcome.
Thank you. Should this monitor be working? Ah, okay, good. Then I'm just going to stand and pretend I know what's on my slides. So, yeah, I need to hurry a little. Those should be skipped. That's not in the PDF. I'm sorry. So, when you think about observability today, something which often happens is you have a lot of disparate systems, and you need to rethink while you are in an outage or while you're trying to debug a problem. Like if something is maybe orange is good in the one system and green is good in the other system, or the graph is subtly different, you have a different scale, different name. It takes a lot of mental overhead and effort to really understand what is happening. And in particular at 3 in the morning, that's a bad thing. By extension, this also makes it harder for you to externalize this into computer code. So not only does it make this harder for you as a human to move and understand what is happening, but also it makes it a lot harder to put everything into code and basically put yourself out of your today job and do a more impactful job tomorrow. Also, one editor's note, apparently the export of the PDF includes skipped slides, so I will sometimes apparently have to click more often. So, let's rethink how these disparate systems can be done, and also let's really walk back a lot and come back to the basics of how humans have dealt with data over thousands and thousands of years. Ever since we have had written records, humans always went through the same optimization chain. And by extension, I'm arguing that we should do the same in computer science. So if you look at this is a power meter by Yanitza. They are the market leader, the European market leader for power measurement. And what you can see is, on the one hand, a graph, basically how good the power is as it comes in. Do you have any desynchronizations on your sine wave and everything? And also you have logs. The pattern, which you will always observe in any established industry, is that the vast majority of data is going through numbers, because numbers are the most efficient. And anything which is really, really like a short time or really important, let's say a power outage, or let's say a security incident, or something which is money related or something, you put this as distinct events, because those are more important, and there you can pay the extra overhead of storing this. I'm going to talk more about this once I'm done with my history lesson. This is the Stahlschlüssel. This contains every type of steel which is being produced on Earth. This book has been in publication for over 100 years, is re-released every few years. Every single steel manufacturer on Earth, with all the properties of all the steel which they're offering, including manufacturing quantities and everything, is in this one book. All the properties are just numbers. The chemical composition, the tensile strengths, the everything, it's all numbers. Without steel, I mean, the world wouldn't work, and everything about steel is in the numbers. There's a logbook, the classic example for logs and where the name is coming from, where when they were on the high seas with their ships, they threw the log overboard. They counted the knots on the rope which they tied to that piece of wood. That's also where the speed in knots is coming from. And this is how they determined how they were on the high seas. And there's something very easy. If you're sailing on the high seas and you don't know where you are, you die. It's very easy. So this book was absolutely sacrosanct. The absolute most important information about this book was put in there. And over time, obviously, they also started putting in like cargo, who got paid, all of the essence of the book as to the outside interface to the world. This is the oldest letter we know of, like 4,000-year-old. It's a complaint letter about someone selling the wrong grade of copper, the seller being not nice to the servant of the buyer, and also the seller making provisional payment. This is basically the full story of what happened, but it was an important transaction. And this is the oldest writing which we know of that is most likely tabulating who owned what slaves. My point here is this. Humanity always goes through the same cycle. Something is worth doing, I write down the whole story. as this keeps being worthwhile, as I keep doing this, this becomes too expensive. So I start to extract the key events. This makes it much cheaper and much easier to deal with all my data. As I keep doing this, as this keeps being worthwhile for whatever I'm doing, this becomes too expensive. So at this step, humans have done the same thing over and over again. They have put information in the best and the most dense format which we as a species know of, and that is numbers. Numbers are great. You can do math on them, you can store them really efficiently and cheaply, you can do large-scale statistical analysis on them. They are absolutely great. And any established industry, again, is fully numbers first. Like if you get paid, you get a number into a number. That's the money into your account. Then you consume your water, electricity, and internet, whatever. You get numbers from them. That's the consumption. You get another number. That's the price per consumption. You get another number. That's what you have to pay. And you send that number to a number, and that's their account. It's all numbers. And yes, by extension, because IT tends to be log first, my argument is that a lot of IT is not yet super mature and optimized and could be doing better. I should have been on this slide, but I don't have a monitor. Anyway, let's look a few buzzwords and other things. So observability is a super cool buzzword. And no one is doing monitoring anymore. Everyone is doing observability. Of course, this makes your boss more happy and it gets you more money maybe. And also you sell better. Just call the old thing by the new name. And that is how you do it. But the thing is, buzzwords usually have a kernel of truth, a reason why they have been successful. Who here has heard of the term cargo culting? Oh, surprisingly many. So for those who don't know, this comes from the Second World War, where during the war effort in the Pacific Islands, a lot of soldiers came to remote islands, some of which had never had contact with humans before, or at least only very controlled contact with humans. And those weird people, like the indigenous people, observed those weird other people coming and clearing out forests and building little fires and turrets and walking around. And they did all this, and all of a sudden, the gods started sending gifts from heaven. Those were planes and ships dropping cargo for the war effort. But the indigenous people didn't understand this because they didn't have the context of what was happening. So they just observed the behavior of someone is clearing the forest and they're marching along. And also all of a sudden, huge amounts of cargo come to this island and everyone is rich all of a sudden because they have all this stuff. They did not understand what was happening in between. And this power is so strong that even through these days, where those people absolutely 100% understand what was happening, they still have proto-religions in the region, which is where the term cargo cult is coming from, where they still do small marches, build control towers and landing fires and everything as part of their local traditions and religion. This is how deeply this desire to copy and to emulate perceived success is ingrained in humans. So it's not a bad thing for everyone to just try and do the thing which is so successful. But also a lot of salespeople will just tell you, oh no, it's complicated, and then sell you more stuff. So monitoring, my own, like I use them interchangeably, absolutely. There are, let's skip this. Observability at the core is about enabling people to understand stuff, to understand systems, and by extension, again, to make computer systems understand stuff. There are some functional tests for the term observability. Those are the ones which have initially made the term popular within computer science. If you cannot ask new questions on the fly, it is not observability. If you can only determine that something is broken and not why something is broken, which is basically the same thing as the other definition, it is not observability. So those are functional definitions. They are not super precise and useful, and maybe sometimes that's in favor of the salespeople. I've also seen in seriousness, have seen terms suggested as observability 2.0 and 3.0 and 4.0. And on the internet, everything goes up to 11. So let's just call it observability 11 and be done with it. No, my point here is you can see how this is still the buzzword cycle. Like if I have to try and redefine a term which has been a few years old, probably I'm trying to just keep the hype cycle alive. But is it only a few years old? So the initial first scientific reference which I could find is from 1809 from Carl Friedrich Gauss. That basically what you have to do is you have to make more observations about the absolute of the state of the world, like a little bit more than you absolutely need, because you might miss some. to be able to make determinations about the state of the real world. And same as we currently with cloud native and all of this explosion of services have vastly more data, in the 60s or in the 50s, something which happened is industries and factories became too large and they couldn't have this one person who knew everything, and they had to actually do science on how to make this comprehensible if more than one human has to share the understanding of what is making the money and the products. So they invented control theory and poured a lot of money into universities to study control theory. And this is where this definition is coming from 1960. Observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. That is the scientific definition of observability. You do not need anything else ever again, because this allows you to reason about, is the system actually able to tell me about itself, or do I need to add more signal? Or maybe can I take away signals, because I'm just paying too much, and dial in that I have just a little bit more than I absolutely need, and that's the perfect happy place for observability and the amount of data which I'm generating. We also have to talk about complexity. I personally like to discern two different types of complexity, fake complexity and real system inherent complexity. Fake complexity, get rid of it. You do not need that new JavaScript library. You really don't. Like, you have to collect them all, but not here. So you don't always need extra complexity. Important point, if you are in a regulated business, like finance or whatever, those laws and regulations are very much fake and invented, but they are very real for you. So yes, they do apply and you have to take them into account. Real system inherent complexity, you cannot get rid of, because this is part of why you even have the thing which you are responsible for. Otherwise, it wouldn't exist. So you can move it. It doesn't really matter if it's on a mainframe in a monolith or if it's in a fully cloud native microservice, blah, 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 horizontal, scalable, whatever. Doesn't matter. The complexity itself lives somewhere. You must compartmentalize it, else you cannot understand the total amount of complexity. You must put in layers where you can understand. It should really be distilled meaningfully, so you can actually understand it. And again, you can't reduce it. So what's a service? Services are compartments of complexity. And they usually have different owners and teams and everything. And the interfaces are traditionally called APIs. I prefer the term contract, because a contract is something like API, I just change it, it's the other person's problem. But the contract, I have to sit down, I have to talk, I have to agree, I have to write it down, everyone puts their name to it. This is the agreement, this is the contract. Oh, okay, we're going to speed up. The other thing which we have here is the term layer. The internet is basically a just layered on top of each other. It doesn't matter if you have fiber or if you have Wi-Fi. It just works. There's plenty of other examples. Cloud native, it does again not really matter where your complexity lives. The main thing about cloud native is you can break stuff up into horizontal units and you can scale them horizontally. It's easier to scale horizontally than to scale vertically. But the other unspoken part about cloud native very often is as I have my hard API contracts, I do not have to have my people talk to each other as much. The teams don't have to interact as much, which means they can spend more time engineering and actually doing stuff which is worthwhile, instead of just having endless meetings, by making those compartments of complexity smaller. I just allow them to work more independently as long as they have good API contracts. But there's a problem. I'm deliberately breaking up previously well-contained units of complexity. Previously, I had my one binary running on my Linux machine, and I had top and all of those tools, and I knew exactly what happened. But this is not true anymore. This is now fundamentally different, because by making those compartments of complexity smaller, a lot of the interaction between those compartments of complexity, between those services, have been exposed to the operator, which previously were just hidden behind relatively well-defined interfaces. And if you look at, for example, classical monitoring solutions, they are often designed for a world in which I have my 1 or 5 binaries on the server, and I have maybe 20 servers, and I have a database on every one of those 10 servers, and a web server of every one of those 5, and whatever. This was a very well-defined and very static system. I would maybe introduce a new server every month or every week, unless I'm super large, certainly not every day. Sometimes systems and servers would run for years and years. It was very static and stable. And exposing all of this complexity and allowing everyone to work independently of each other against hard API contracts allows everyone to ship all the time and to deploy new code all the time. And that is why you see observability as such a new term in the industry, because the old style monitoring, even though it is fundamentally the same, the tools which we call monitoring tools are designed for a simpler world where you have a lot less exposed complexity and a lot less moving pieces at the same time. And that is why a lot of the more classical solutions are hitting walls and just cannot cope with what amount of data we have in the overall cloud native and other spaces. There's also something called SRE, Service Site Reliability Engineering, which Google has initially propagated, which is basically just a fancy word for keep the site up. But the thing is, if you have a classical company, you have a lot of fighting between each other. You have the developers, they're paid by shipping the most possible code. You have the operators, they're paid if the stuff doesn't break. You have the product people, they are paid if the roadmap is hit, and you have the research and UX people and such, and they get paid if they do a lot of A/B testing, give new data. So everyone is fighting each other, because everyone has their own priorities, and this creates a lot of strife. But there are different concepts, and to me the core of SRE is this concept. Let's say you go out, you say with 5 friends we are going out for the night, and everyone looks for a few restaurants. If you agree on a budget, you know roughly what you have to do, and everyone can just look at what you can do, and then you just come back together and you won't be completely out of line. Because you have a shared language, you have a shared resource, and this is what aligns you even if you're not talking to each other. Again, a well-defined API and contract, not only on human terms this time. Error budgets are precisely this. Error budgets are the concept of how does the user perceive my system? It doesn't matter if it's breaking because there's so many new features shipped. It doesn't matter if it's breaking because the code is super brittle. It doesn't matter because it's breaking because I don't have enough resources. It is breaking from the perspective of the user, and so I have to fix it here. So if the developers write really bad code and it's breaking all the time, they don't get to ship new features, they don't get paid for the features. The product people don't get paid for hitting the roadmap. So they are going to be unhappy, and they're going to be like, no, we need to fix this, this needs to become more stable. And this is how you can drive a dynamic and how you can actually force people and align incentives amongst people without them even having to talk to each other, because everyone is on the same page. Measuring all of this, SLI, SLO, SLA. SLI is the service level indicator, what I measure. SLO is the service level objective, what I have to hit internally, and the service level agreement, SLA, is where I have to pay someone externally. If you have heard the term KPI, more on the finance and management side, precisely the same concept, but basically mixing all of those three into a melange. So I prefer those terms because they again have layers, and it's more clear what aspect I'm talking about. But if you're talking to a business or finance person, you can just tell them, okay, this cool SLI, SLO, SLA thing from the SRE book, that is just KPIs. And all of a sudden you speak a shared language and you understand each other. You don't have this issue of, oh no, we are not even speaking the same language. Personally, I like to discern between different SLIs, because if the stuff I'm relying on is on fire, my debugging can be quicker. I need to confirm that, yes, this is actually the root cause of my outage. It might be different. But once I have confirmed this, either I can go back to sleep, or I just help the other people fix their stuff. We can also start building a shared understanding. That shared understanding comes in many different forms. I mean, I'm standing here for Grafana, so you can probably guess where this is going. But once I have a system, a similar system where everyone is putting their data, I start using the same language. Again, KPI, SLO, SLA, SLA. If the dashboard is in the extreme just called the KPI SLO dashboard, I'm starting to build shared language. I also pool my knowledge. So this one database person makes a really, really awesome improvement to this and that dashboard or alert or whatever. And all of a sudden, all of the other teams who are also using databases are also having the advantages of all of of all of those improvements. They don't have to improve the dashboards and alerts themselves. They just get it for free because someone did it in another part of the org, but as everyone is using the same tooling, everyone gets the same improvement. Same for all the other things. And you really start building a shared understanding of the world around you. Meaning, if you have, like you notice, you go into a meeting and 3 different people start the meeting with a discussion about whose data is least wrong. And everyone is fighting about, no, my data is better, and no, this graph is better, and whatever. If everyone is using the same database, or the same data at least, and using the same visualizations, you don't have this argument anymore, because you already went as an institution, as an organization, through a phase where you pooled your knowledge and your everything, your expertise, and you agreed that those are the numbers, and those are the graphs, and those are the everything which you want to rely on. So you don't have to have this fight every single meeting. And it becomes, again, a lot easier to just have a discussion. You just send over this one email with a report and say, hey, here is a problem. And you don't have to be in a fight about, no, your data is wrong, because everyone who receives this email is agreeing, yes, the data is probably right, and I probably need to fix this. They don't have this cop-out. That's probably all we have time for. That's the last one then, alerting. I have been on call, myself, not anymore thankfully, but I have been on call for 11 years of my life without break or holidays, because I'm an absolute idiot. And I can tell you I would not be married if I didn't have good on-point alerting, because I just, like, it wouldn't have worked, like, wouldn't. Not joking, it's like, I mean, it's kind of funny, but it's also not on some levels. Don't be as stupid as I am, don't do unpaid on-call, and don't put away the pager during holidays. Anyway, the point here is you can burn out super easily. And one of the only ways I was able to not just explode was to aggressively reduce the amount of stuff which sent alerts. And one of those lessons which I learned very early is I can only alert on stuff which is currently or imminently customer facing. If I have 20 database servers, 18 are on fire, and the customer is still buying shoes and they're being happy about being able to buy shoes on my web shop, they don't care. I don't need to wake anyone up. If my SSL TLS certificate is going to run out in 2 weeks and is on a Sunday on 3 a.m., I don't have to wake anyone up. They can do it during business hours. Only wake people up, only scramble them when really the people who consume the service, internal or external, are the ones who are having problems. That's all we have time for. Thank you.
Thank you very much. Any questions? Yes.
Thank you. Thank you. I have a question about, should you be alerted about service being in danger? So it's not down, but it will be down, say, in 2 hours. Should you get an alert? What do you think?
So depends. If I'm certain it's going to be in 2 hours, I would probably send an alert, because this is imminently customer facing or user facing. But there are, like, for example, there are those 99% disk full alerts, which are absolutely horrible. Just make a prediction, easy with Prometheus. Just make a prediction of when will I run out of disk space. And if this is in 3 years, of course I'm growing very slowly, doesn't matter. 2 hours, I would say yes. At least if it's important. If it's not important, whatever.
Thank you.
I think there was one more over there.
Yeah, a quick question regarding 2 of the slides. First is the terms that you have used and this alerting. So when it comes to terms and the buzzwords, I have consistently started coming across a new term called as applied observability, which is not just monitoring and alerting, but the tool itself has some capability to take some corrective actions on behalf of the user or the admin. So for example, if the alert says that a particular job or a query is consuming 80% of the CPU, the admin would write a small script and ask the tool itself to kill that query right away, so that the admin doesn't have to wake on 3 a.m. on a Sunday morning. So does Grafana fall under observability or applied observability, or like, just wanted to understand your take on this new term?
I don't think that's very new, to be honest. I mean, the term, whatever, people invent new terms all the time, but like this is the absolute classic cycle of improving anything. Something is not working right. I have to understand why it is not working right, how to fix it. If it happens more often, I need to find a way to fix it reliably. And then we are at the point where you just described, where you want your alerting to automatically take corrective actions. I'm not a big fan of this. I'm a much larger fan, and this is what we do within Grafana. Once I am at the point where, as you say, the operator is able to write a small script, they have enough understanding to actually fix the code and prevent this type of problem from even coming close enough to become a problem. So I relatively strongly believe that it is a mistake to wait so long. You should fix it earlier because you already have all the knowledge. You built the runbooks, you built your understanding of why this alert is happening enough to build a script, then just fix it in the code. There's one caveat, something which like we are also working on and already seeing internal success with is where like common cases with LLMs and such can be done in a way where you have a new, not a known, a new thing, and you have recommendations of, okay, this will probably fix it, and then you can apply this in a tool-driven way. Yes, that's different, but once you have the human understanding, fix it. Don't do applied observability or whatever.
Got it. Thank you.
Yeah. There's one more here?
Yeah.
Okay.
Any more questions?
I think there's one here.
I just really just like to echo and support what you just said and what your earlier slide pertained to. I always say that architecture protects you against accidental complexity so that you can focus on the actual complexity, which is what you said before. And what you're describing here is you need to understand what problems are structural and fix the structure rather than just putting Band-Aids on top of everything.
No.
Okay.
I have one more question. What do you think about using probability to detect imminent danger?
What do I mean?
Like some distributions, for example.
Yeah,
What is
I get it.
probability of the service goes down like in next 1-2 hours?
So in the abstract, not very useful because in any large data set you will always find correlations. So for example, climate change and the amount of pirates is an inverse relationship over like 200 years. It's relatively robust except for the last like 10 years, but up to that point it was very, very robust. And in any reasonably large data set you will always find correlations. But once you add some understanding, yes, absolutely. 2 examples. One thing which I love doing in Prometheus, you can just look at the double exponential fall-off, which basically both gets rid of cyclic oscillations and also short-term oscillations. And you get a smoother graph of what happened with whatever over time. And then you just define a 10 or 20% boundary around whatever your line is. And then the outliers of this are probably a problem. That's a good example. Another good example would be Explore, which we have in Grafana, where we just do the heavy lifting of all the boring data analysis and just show potentially interesting correlations or outliers or whatever, or drop-offs or time correlations or whatever. And then the human in front of the machine can see, okay, this is good, this is bad, this I have to explore. No, it's not good, I pull out, I go deep here. Basically this combination of a lot of boring computer work and then using subject matter expertise to make the determination of if this is actually the case. If I rely on a fully automated chain, I will have false positives. I will also have false negatives, but that's not in this case. Okay, so have the human, like support the human to understand to the point and then automate it away.
Thank you very much.
Thank you very much.